Of all the standards we teach in kindergarten, this might be the toughest. It's those tricky teens. So in this video, we'll take a look at what teaching NBT 1 should look like in a kindergarten classroom. With this standard, students should compose and decompose numbers from 11 to 19 into 10 ones and some further ones, and to understand that these numbers are composed of 10 ones and some more. Students should have an opportunity to do this by using objects and or drawings, and they should be able to record each composition or decomposition by a drawing or an equation. In kindergarten, they're both not mandatory. So let's take the number 15, for example. When students begin tackling this number, we might want them to really begin building that understanding of unitizing. So we'll use the structure of a 10 frame, where here the students have a group of 10 and 5 more ones. But every time students work with team numbers, they might not have a 10 frame, or we might not want them to have that structure of a 10 frame. And instead, we want them to build that structure. So we move the 10 frame, and we're left with a bundle of 10 ones and 5 more ones. As students begin to work through these numbers, just like we do with the numbers 0 through 10, I'm continually formatively assessing what my students can do and what they can't do and what they understand. So as students begin working through the number 15, we get them to focus on rote counting. Do they understand that sequence and order of numbers? Then after they understand the sequence, can they tag it to an object? Where here we're working on one-to-one correspondence. Then as one-to-one correspondence is developed, students need to understand that the last number in the count sequence represents the quantity of the set. Here, our last number in the count sequence is 15, so we have 15 red dots. Then there's this idea of hierarchical inclusion. I know it's a really big word, but what does it mean? Well, if students understand that they have 15 of an object, they understand that they have to have at least 14. Students begin to build this understanding that numbers are nested with inside each other. And this idea of hierarchical inclusion, well, it lends itself beautifully to the model of number conservation, where students can see that numbers can be composed into parts of a whole. And this decomposing of numbers, well, that's what the heart of this standard's after, that NBT1. How do we get students to see the tenness and structure of numbers? Another great tool that we haven't talked about yet that allows students to see and build that idea of unitizing is a rec and rec. Here, when students use a rec and rec, what they can do is they see that they have a group of 10 and 5 more red ones. That way they build the number 15. But what's great about the rec and rec is that it also allows students to build and see tenness a different way. Both ways there's a bundle of 10 and 5 more. So let's see what this looks like in a classroom. In this game, what students are doing is rolling the dice 4 times, and then they actually estimate, because estimation is something that students don't do enough of. We need them to understand the magnitude and size of numbers. So here they roll 4 times and count.
Get your cup for me. So this is your cup. How many did you think was in here? 99. So you think there's 99 in there? Okay, what do you think? Do you think there's 99 in there? You think it's 100? Okay. She has more guesses than you. That's right. Okay, so go ahead and pull them out and count them for us.
As students begin to count, I'm looking for all of those look-fors that we talked about before. I'm looking for, do they have the count sequence? Do they have one-to-one correspondence? And then I'm also going to see if they have that cardinality after they're done counting. But you could also see here that the estimation of 99, that's a lot more than what was actually in the cup.
All right, so how many was here?
15.
Okay, so let me ask this question. How many did you think was in there?
99.
So was your guess more or less than 15?
More.
Was it a little more? Was it a lot more? Was it way, way more? What do you think?
It was way, way more.
How do you know that?
Because 99 comes before 100.
99 comes before 100. And how many were here again? Do you remember?
15.
Okay, so can you draw 15 dots for me here?
So as mentioned in the opening, we might not always want to use 10 frames for students to see that structure. So here the goal is to have students use that one-to-one correspondence for 15, and then we're hoping that they'll be able to group it into tens.
All right, so how many dots do you have there?
15.
15. And so how could we tell that there's 15 there if we didn't want to count them all one by one by one?
Circling the tin and then you see 5 more left.
Oh, I love it. So can you show me what that would look like?
No. Yeah.
So again, as students are counting, I'm continually running through my formative assessment look-fors and seeing if they have true understanding of what they're doing.
All right, so tell us what you did here.
I circled the tin and then I saw 5 more left.
Okay. And so how would you write the number 15? So you have how many? Can you put 15, write 15 in that last box?
Okay, count them. Okay. Oh, I need to make my guess. I think it would be 50.
Nice. Okay, awesome job.
Standard of Mathematical Practice number 3 says that students should construct viable arguments and critique the reasoning of others. I want to continually ask students to prove what they know. And sometimes students, well, they'll kind of check each other's understanding. And that's what this standard's about.
Okay, so what's the problem here?
We're always supposed to circle it if it's a 10, but that's an 8.
Where's an 8?
In the circle. This is 8 and then 1 more.
So what's 8 and 1 more?
9.
9? Okay, and what were you saying?
We're always supposed to circle it if it's 10.
Only supposed to circle it if it was a 10. So if this was a circle of 10, and it had 1 more, how many would that be?
11.
11? Okay.